Hi friends, Mrs. Crane here. This is going to be your part 1 of lesson 9, and it's pretty easy. It's pretty straightforward. We're going to jam through it a little bit. You may need to pause a couple of times because I am trying to get this done before my staff meeting. So what we're going to do today is we're going to talk about a diagonal line, and diagonals make triangles when you put them in a quadrilateral. If you draw, it says a diagonal connects opposite angles of a quadrilateral, so you can make triangles by drawing a diagonal in any quadrilateral. So what we're going to do is we're going to be listing names of quadrilaterals, because remember we filled out that graphic organizer a couple of days ago about quadrilaterals, and there are parallelograms, there's rectangles, rhombus, square, trapezoid. So we're going to look at these figures and we're going to give them names, but then we're going to add a diagonal, as you can see on number 1, a diagonal from upper left-hand corner down to the right, and then upper right-hand corner down to the left. And we're going to name the triangles that are also present. So when we're looking at number 1, what's the first quadrilateral that comes to mind? Square. I hear you. But what else can this be? It has 2 sides that are opposite, parallel sides that are opposite, so it can be a parallelogram. It has equal sides, 4 equal sides, so it can be a rhombus. And it has 4 right angles, so it also can be a rectangle. So I kind of shortened it, so if you want to do some shortened words so you don't have to write the whole word, I'm okay with that. So I wrote square, parallelo, which is parallelogram, rhombus, and rectangle are all names for this first, number 1, figure. Now if we add a diagonal, we have triangle A, B, C, and we have triangle C, D, A. What kind of triangles are those? Well, it's a right triangle, right? It's a right triangle. And if we do a diagonal in the opposite direction, we have triangle B, C, D, and we have triangle D, A, B, and those also are right angles. So hopefully you're starting to see what we're going to do. We're going to name all of the figures that are happening here as we add in diagonals and before diagonals. So if you're looking at these, here we have a figure with 2 sets of parallel lines, 2 sets of opposite parallel lines, and all 4 sides the same. And then we have a diagonal and a diagonal. So here's what we have here. I thought I heard you say it. This can be considered a rhombus and a parallelogram. So if I create, by adding the diagonal in this quadrilateral, or rhombus or parallelogram, we have now triangle E, H, G, and triangle E, F, G. And I know that at least one of these angles is obtuse or greater than 90 degrees. So that automatically makes it an obtuse triangle. Both of those are an obtuse triangle. I'm sorry, not obtuse, Mrs. Crane. I wrote the wrong thing. It's acute, right? Because all 3 of these, for it to be an acute, have to be smaller. So acute triangle. At least, if I do the other one over here, we have H, E, F, and see this angle right here is greater than 90. If I look at that, that's greater than 90 because 90 would be here, right? Then we have F, G, H, and this right here, this line right here would be 90 degrees. So I know that this angle right here is obtuse, and all it takes is one obtuse to make an obtuse triangle. So our next set of figures, a rectangle, right? I hear you, but it can be also called something else. A rectangle can also be called one other thing. It can't be called a square because a square has all 4 sides that are equal and a rectangle does not. So what could it be called? I hear you. I hear you. I hear you. Parallelogram. You're right, because we have two pairs of sides that are parallel. Now, when you add in that diagonal, now you have two different kinds of triangles, and this is how we would label them. So you have a rectangle for the first figure, a rectangle, and a parallelogram. And like I said, I have a couple of shortened words here for you, so it makes it a little faster. We have triangle J, M, and L, and this tells me that's a right. And we have triangle J, K, L, again, right triangles. And then if you do the diagonal in the opposite direction, you have K, L, M, and triangle M, J, K with a right. Now, I know I'm going fast because I feel like I'm going fast. Anytime, pause, rewind, pause, right, pause, look at the screen, whatever you need to do. That's the beauty of this whole magical world of video. You get to do that. Now, if we were doing this in class and I was going this fast, it wouldn't be cool. But I know that you have the power to shut my mouth at any point in time. So, we're going to look at the next page. It's the same thing. We're going to have some more quadrilaterals that we're going to make some triangles with a diagonal line. We're going to use letters to name the triangles you make with the diagonals and tell what kind of triangles are. So it's exactly the same thing we did on the first page, but we're looking at a new set of pictures. So our first set of pictures look like this. And number 4 is pretty straightforward. There's no right angles, so it can't be a square or rectangle. All 4 sides are not equal, so it can't be a rhombus or a square. So I think it's pretty straightforward that it's a parallelo, right? Parallelo. Now, if I make a diagonal this way and a diagonal this way, we label our triangles N, O, P, and P, Q, N. All 3 sides have to be cute. So here you go. Acute, 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 acute. All less than 90. So these would be all acute triangles. We've got the same thing going on over here. We just might name it a little different. N, O, Q, and O, P, Q. And those also are acute triangles. The whole objective of this lesson today is to see that triangles can be put together. 2 triangles can be put together to make any quadrilateral. And it's also a good practice for us to name our quadrilaterals and to name our triangles. Here, I love this one. He's the Lone Ranger. What do we call this guy? It only has 1 set of parallel opposite sides that are parallel. That's right. It's our friend trapezoid. And on this one, with your diagonal, you've got 2 different kinds of triangles. You've got one that has 3 acutes. So you've got 1 acute triangle, and then you've got one with a really big one that makes it obtuse, because it only takes 1 obtuse angle to make an obtuse triangle. And then over here, you've got 2 obtuse triangles, because 90 degrees, any angle that's even slightly larger than 90 degrees would be 90 degrees. So you've got triangles RST, RST, and TUR. And over here you have triangle STU and URS. Hopefully you're starting to see the pattern, because we've done 5 different objects. Here's our last object. It's another one that only has 1 set of parallel lines right here that are opposite each other. So it is our friend trap. But the thing we can say about this one, that it has 2 right angles. You can't always say that. So here's our diagonal here. Here's our diagonal here. and this is how we would label them. So triangle VWX would be the obtuse one, because that one is larger than 90 degrees. And triangle XYW is a right triangle. Similarly here, we have WXY is acute, because all of these are smaller than 90 degrees. And then YVW is a right triangle. Now, like I said, if you need to pause, you can pause, but hopefully there's a pattern to this, and it's partly practice naming our figures. Tomorrow, we will do 329. It is imperative that you have 329 because we are going to do the cutting out of the triangles. You can make a quadrilateral by joining the equal sides of any two triangles that are the same size and shape. So here are some examples here. If you put these two triangles together, you get this shape. If you put these two triangles, it's 1, 2, 3, 4. You get 4 sides. 1, 2, 3, 4 when you put the two triangles together. So if you want to try this, you can try this, but I don't know if you can cut it out. I'm not sure what's on the other side, but you could cut out and join the sides together and write what you think the quadrilateral is. You do have that definitions page still hopefully with you. If not, it's in class and the basis has been laid that you can add a diagonal line to opposite angles in any quadrilateral and you're going to get a triangle. We're going to do more with this tomorrow, and part 2 will be ready for you tomorrow afternoon. See you at school.